Okay. Hi everyone, I'm Mohammed and this is Jading, and today we're going to talk to you about Mycon. So everyone knows that smoking is a very common habit, and in Canada alone there are 100 people that die every day from smoking related illnesses. So there's a therapy method called motivation interviewing, or MI for short. It's used to resolve ambivalence and empower change, and it's used in cases like smoking, drug addiction, and alcoholism. So recently, chatbots are being developed that can deliver MI-style conversations, but we have to make sure that the messages sent by these chatbots are actually MI consistent. We define MI consistency of a sentence according to the MISC code that's assigned to it. And MISC stands for Motivation Interviewing Skills Code. So these are examples for MISC encoded sentences. So for the first example, you'll see that the clinician is giving advice without asking for permission, and that's MI inconsistent, as opposed to the second example in which the clinician gives advice but after being granted permission. So for our project, we're developing two classifiers. The first classifier is end-to-end, and it uses triplets as inputs, and that's what a triplet is. And it classifies the last response of the clinician. And for the second classifier, we classify the MISC code for this last response. For data collection, we're using a data set called ANO-MI. It has whole therapy sessions, and it labels every session as being of low quality MI or high quality MI. We also parsed some data from Reddit to get more negative examples. For the data preprocessing, in the positive examples, we used triplets from the high quality sessions in the ANO-MI dataset, and we labeled the last response of the clinician in each triplet, and we skipped any triplet that has questions in the last response.
Now, just because a sentence appears in a low quality session doesn't automatically make it MI inconsistent, which is why we need to manually label each triplet and only keep those ones that are definitively not MI consistent and give them MISC encodings. Sometimes the sentences have mixed MISC encodings, and we'll separate them into individual triplets, and we use our own imagination to make up the missing parts. Imagination is what we need the most for the Reddit examples, because we basically just take the post that has negative sentences, and we would come up with a way for them to appear in a therapy setting, and then we'll give them a MISC encoding. After going through the entire data set, we were only able to get about 200 triplets. Half of them are positive and the other half negative. Within the negative, about 80% are from ANO-MI and 20% are from Reddit. We used the baseline model to be GPT-3 DaVinci in a zero-shot setting, and we designed our prompt and followed the settings by following OpenAI's guideline to use GPT-3 as a classification model. And for our own models, for the end-to-end, we used a fine-tuned version of GPT-2 as well as GPT-3. And for the multi-class model, we just tried GPT-3, and the output is the 5 negative MISC encodings, as well as one other class called other.
So for the end-to-end results, for the baseline model, it got a 51% accuracy, and it classified nearly all examples as MI inconsistent, even for the examples that were clearly MI consistent. For the fine-tuned GPT-2 model, it got a 62% accuracy, and it classified most examples as MI consistent, even for the examples that were clearly inconsistent. And for the fine-tuned GPT-3 model, it got a 91% accuracy, and actually the examples that it got wrong were a little bit confusing even for ourselves. So what we've learned about these experiments is that the baseline model probably doesn't know what MI really is, and we think that the GPT-2 model would have performed a little better if it was fine-tuned with a bigger training set. And it was no surprise that GPT-3 performed better than GPT-2 because it's a much more complex model and it's trained on a lot more data.
You can see how the multi-class task is a lot harder by looking at baseline model accuracy. The per encoding accuracy is only 22%, and if you were to use it as a binary, then it's 70%. However, after fine-tuning, it reached a per encoding accuracy of 63%, and if you were using it as a binary, then 92.6%, which is pretty impressive. It is kind of still lower than our expectation, and we think the main reason is that we need more data since we have less than what's recommended by OpenAI themselves. And even though using the multi-class as a binary is slightly better, we need to take it as a grain of salt because our test data set is relatively small. And some discussions are GPT-3 it's not omnipotent out of the box, but it is able to do pretty well after fine-tuning. And model size makes a big difference. If we were to do this project again, we'd spend even more time getting more data, doing more manual labeling, and we'd probably start with the newest and largest model right away. Thank you for listening.